Hey guys, I'll try not to let my frustration. This is the second video. The first one, which I did, was like an hour and 20 minutes and shit the bed when I finished. So hopefully this one goes a bit better. Let's start off with this for the second time. Okay, so this is the PowerPoint presentation I put up on the website. And let's work through this. Alright, so I mentioned it before, you have your startup and your running configuration. Your startup configuration stored on NVRAM. And the file only exists when you actually back up a configuration. If you delete the startup configuration and reload your router, you'll see the little thing saying, hey, do you want to set up your router? Little message there. We'll come across it shortly. And that's only if you don't have any sort of configuration file backed up. So if I were like off a blank router, if you would try to view what's in the startup configuration, it'll give you an error because there's nothing there yet. Your running configuration is everything that you've done after you've booted. Okay, every little change that you make. Just remember that every change that you make does not save into your startup configuration unless you manually do that. So that's very important that you do that, because you can, if you're like deployed and you drive to a remote location, fix what's wrong with the router, and then leave, and then they have a power bump, and everything you've done, if you didn't back it up, is gone, and then you have to go do it again. So every time you do any sort of work in the router, every couple minutes, just back it up to be safe, you know? Very important. Okay, saving the configuration, copy running config into startup configuration, or copy run starts, or write memory, or write mem. And again, this copies what's in your running configuration into your startup configuration. If you want to erase your configuration, you do that. Now that only erases the startup configuration. When you put the command in, you're not going to see anything different. Your router is not going to stop functioning. It's just going to keep working normally. You won't see that everything's been wiped until you reboot your router. Yeah, show start, and show running. Show run is going to be one of the most common commands you'll use, period. Anytime you have any sort of issues while you're configuring the router, just pause and do a show run. 99% of the faults when you're with networking is some sort of configuration issue. And just doing show run, you do a quick overview of everything that's been in there and go from there. It's a good starting point for troubleshooting. Just make sure you read through this quickly. Not what I'm doing. Okay, so if you don't have a startup configuration in your router, that's what you'll see when it boots up. Just say no. The wizard sucks. Don't do it. Okay, if you see this ROM-on1 greater sign, you are not in the iOS. You are in like ROM monitor mode, which is like DOS, like the DOS for routers. There's not a whole lot you can do in there, and if you're in there not by choice, something critical, some sort of critical failing has happened. First one being the router could not find the iOS where it's stored. Second one, you could have a corrupt iOS, and third, you can force yourself into it. It's control break, I believe, on startup. Now that will make you ignore the iOS and boot into ROM-mon mode. Those are really the main reasons how you'd end up getting there. If you're in there, you're not knowing you're going to go in there. Everything gets kind of funky. If you push certain keys, funky characters will pop up and stuff like that. It just throws you off if you're not expecting it. There's very limited things you can do in there. User mode, there's almost nothing you can do in there. Just view a few things. Privileged exec mode, you can start actually making changes. And then global configuration modes, where you do the bulk of your configuration stuff. Again, you'll always know where you're at by just paying attention to what's in front of the router name. Other like sub ones are interface, controller, line, sub interface, router. Exit and end are going to be the more common ones you use to navigate back from where you are. Exit will take you back one menu, and will take you all the way back to privileged exec mode. Question mark is one of the most useful tools in this. Anytime you're not sure what command you should be putting in, just question mark, and then everything will come up. If you know the beginning of the command, question mark it. If you're a really long command, there's like 5 or 6 words you need in it, and you're not sure exactly the order, put the first one in, question mark, and it'll show you the list. Next one, you can question mark your way right through it. Nice thing is, Cisco has kind of like set the standard for all this, for all other companies to follow, like HP. I've question marked my way through a lot of different devices for programming them. As long as you have a general idea of what you want to do, you can question mark your way through most devices. If you put in a command that's really let's say you put in CO, and there's like 5 other commands that start with CO, it'll tell you it's an ambiguous command. If you put in a command and at some point you start going wrong, it'll tell you where you started going wrong or where it lost you. And that's what that little marker here is. It's telling you, I lost you at this point. I'm not sure where you're going with it. Okay, show version. Show version is really good. It's going to bring something up here. Let's log in. Let's do a show version for you. Show version. There's 2 important things you need to pay attention when we do a show version. One is right here. Okay, that tells your router how and where to look for things to boot up. It's very important to pay attention to, to know what it should be. And the second is this one right here. This tells you your iOS. That's your iOS file name, and it also tells you what your iOS will give you. Again, Cisco routers can do a million things, but you got to pay for them. Example, if you want to do VoIP, you need a iOS that will allow you to do VoIP. Your router can physically do it, but unless you have the iOS to do it, it won't allow you to do it. Programming your host name. Enable, configure terminal, host name, and we put the name in, no spaces. You can use underscores, dashes, whatever, no spaces, and then you can exit back. There's only 2 passwords we normally use, either enable secret or enable password. They're the same password, it's the same for the same thing. Just one's encrypted, one's not encrypted. So use one or the other. I think I'm pretty sure the lab asks you to use both. Just to see that when you put both, if you do program both in, and you can, the encrypted one will be used over the unencrypted one. So when you put in, you're at user mode and you put in enable to get into privileged exec mode, the password that it will ask you will be the encrypted one and not the unencrypted one. It will always prioritize that one over the previous one. It throws people off when they do the lab and they start punching in the unencrypted password and won't take it. Okay, programming your physical console port on the router. That's where you're plugging in your cable. Port that actually says console. So line console 0, the password login. Make sure you put login or it won't try to authenticate the user. Okay, that's very important. These are for your VTY, your Telnet connections. If you don't program anything for your Telnet stuff, people can't log in. Like they can't Telnet into your device, which you yourself will want to Telnet into your device remotely, so that you can manage your device. And that's why it's always taught how to Telnet, just because that's how you're going to remotely manage your device. If you have a password you want to encrypt, you can encrypt it. Okay, router interfaces, they're all shut down by default, so you have to put in the command no shutdown to enable it. Programming of fast Ethernet ports, config T, interface FA01, your IP address, your subnet mask, no shutdown, exit, boom, it's done. Serial interfaces are almost never used. Big point about those is make sure that you add the clock rate to one of the sides. You won't be doing that, but you can if you wanted to. Loopback, you will be configuring. Loopbacks are super useful. It's a logical interface, and there's nothing physical that can go wrong with it. So it's really good, and I'll show you an example why it's good. So if you're this router on the right, trying to always talking to the router on the left, okay, and you're using this port right here, that physical address, and your data is always passing this way, though sometimes it could pass that way if it was if this was really slow. But anyways, it will always be sending it to this network right here, okay, which is like between this interface and this interface, right there to that port. If this network was removed and you didn't know because it belonged to somebody else, or there was a physical break right here, your traffic, like if this network was removed, your traffic 100% would stop. But if there's a break, it may actually stop depending on what kind of routing protocols this router had. So to get from here to there, if this was removed and you were using this IP address, your traffic would just stop being sent. Boom, no more data, done. But if you used a logical interface on that router, then it doesn't matter which way it goes in. Okay, if you removed this network or you removed this network, traffic would still route in regardless. Okay, as long as this router is broadcasting its loopback address, you're good to go. Okay, to configure loopback address, it's interface loopback 0. That's L0, the given IP address. As soon as you input that command, interface L0, it will bring up the loopback address, and you'll see it, the little notification pop up saying that it's brought up. The given IP address and exit, you're good to go. You don't do a no shutdown for it. It just comes up. Show interface, then the interface itself. Again, it gives you all the details in the world about that interface, its IP address, the protocols it's using, everything. Yeah. Whenever I mentioned it yesterday. A lot of people ask you, is the port up and up? The first one is the line administratively, and then line protocol. Those are the ones. So like, is it programmed, and is something physically plugged into it? Okay, if you program it, it's going to be up, but if there's nothing plugged into it, it'll be up down. If you programmed it and there's something plugged into it, it'll be up up. If you don't program it and nothing's plugged into it, it'll be down down. Okay, message of the day. You can program these if you want. D&D uses these for sure. Whenever you log into the D&D router, there'll be a message that pops up stating, hey, this is D&D property. Only authorized people can use it. So that's a normal common thing. If you have any messages you want to leave people that log into it, you can. Then it'll show you how to program a banner or a message of the day right there. Description. Description is an important thing to add in. You are rarely going to be the only person like going in and managing your devices. Often to be other people. If you get a shitty handover and buddy doesn't tell you anything, having descriptions on every port is extremely helpful. Knowing that, like when you log in and you look at the FA01, the description states connection going back to CAF or connection to Kingston. You're like, oh, okay, that's the WAN connection back to Kingston. Okay, good. You can figure out what the router is designed to do or set up very easily. So description is extremely useful. Thing to put in, not so much for yourself, but for other people going in. Let's see, timeout. This just if you're telnetting into a device after 10 minutes of inactivity, you'll get punted out. This just allows you to stay in longer. Logging synchronous. This is again, whenever you're typing something, you'll have a random stuff that pop up from your router. It happens all the time, and if you don't put logging synchronous, that stuff will pop up like where you're writing stuff, and it doesn't actually interfere with what you're writing, but it throws you off. So putting logging synchronous, it moves all your stuff down to a fresh line, and it just makes it look better. It won't confuse you. No IP domain lookup. This is one of the most valuable ones you can put in. If you accidentally mistype a command, rather than sitting there for 2 minutes while it tries to resolve the bad command you put in, just do that. It'll just say either bad command or unknown command or whatever. You're good to go. Terminal length. Whenever you do show run, you'll notice that you have to hit spacebar every once in a while as it goes through. By default, it displays 24 lines. If you set the terminal length to 0, it will just keep spitting out lines until it's done spitting out lines. It used to be really useful, not so much now, but yeah. Okay, switch configuration is very similar to a router configuration, at least when we're talking about very basic configuring of stuff. Host name, same thing. Enable secret, enable password are the same. The same thing for the line con1 and VTY04, same thing. Here though, again, a switch does not, it's not natively a layer 3 device. It generally just operates at layer 2 if you don't do anything to it. So if you want to remotely manage that switch, you're going to want to enable, give it an IP address and enable it to operate at layer 3. So this is how you go about doing it. You go into interface VLAN 1, assign it an IP address, 192.168, what doesn't matter what you assign it. Then no shutdown. It's very important. I didn't do that yesterday, and I couldn't remotely manage the switch at first. It took me a bit to catch that. So no shutdown, and then I'll come up, and then you can start telnetting into the switch itself to remotely manage it. As well as you're going to want to give it the default gateway, and this is how you do that. IP default gateway, and then the default gateway. We're talking about default gateways. It's always your way out of your own network. Okay, so for us, it's always going to be like the inside of our network. So this is our network. So the way out is going to be this port right here. So that's going to be 10.0.0.1. And then if you want, you can manually change the speeds. So 100 megs per second is what that's changed to. Full duplex. You could just leave it on auto negotiate. That's fine. Most devices are set to auto negotiate anyways. Sometimes there's issues if you have one device that's auto negotiate and the other one's not. There could be issues there. If you ever have a speed mismatch, everything will get fucked up. You have a duplex mismatch, everything will be fucked up. And the faults will really kind of vary based off of the device. Sometimes you have a speed duplex, there's a speed mismatch, nothing will happen. It shuts it down. And other times it will kind of work. It'll be up, down, up, down, up, down. It'll be all sorts of fucked up. So, yeah. Okay, that one's that guy right there. Okay, the next one you guys had was applying IP routing. Okay, right now, the first command I want you guys to know is, so I went ahead and programmed a second network right here. Okay, and routers are very not dumb, but they do exactly what you tell them to do. Okay, so if we go into this router right here, and the command I want you to learn is IP route or show IP route, and let's see, password 1, hello, show IP route. Okay, so I programmed a loopback address in both of these. If you look, the router uses CIDR notation. CIDR notation, it's just all the ones that are used, all the bits that are used in the subnet mask for the network portion. It's just them added together. So here we used 8, and here we used 32. Okay, and then this router here, pull that off to the side. Password 1, enable, hello, show IP route. Okay, so when we look at our tables here, okay, I'll tell you right now, traffic will not work. That's not really a good way of doing this. Okay, so when this guy, so this is the, I should put little tabs here. This is the 10.0.0.0/8 network. And this one over here is the 20.0.0.0/8 network. And then right in between, we have the 192.168.0.0/24 network. Okay, so when anybody in this network here, okay, tries, let's say this laptop wants to ping this laptop, he's pinging somebody, he's going to try to ping somebody that's in this network 20.0.0.0. When that request gets to our router, Rod's router, he looks at it and he looks at his table. And let's look at his table right now. Look at his table. He checks there to see where he sends it out. What port do I send this out? Okay? And if he can't find an entry for it, he does nothing with it. He just files it in a shredder. And if we look, yep, he has no clue where this thing's going. So he files it in the shredder. And that's the same story for over here. If this laptop wants to talk to the laptop over here, he'll send the ping out. The ping will go to the switch, and from the switch to the router. When the router gets it, he'll look at his routing table, and he'll say, "Oh, you want to talk to somebody at the 10.0.0.0 network? Let's see. Let me check. Nope. I have no idea where that is," and it just shreds it. Okay. On the other hand, though, if I want to talk to this router, okay, I can talk to this port, because this port is on the 192.168.0.0 network. So when I ping this port from any one of these devices, okay, it gets to this router, and the router goes 192.168.0.0. Let's check this. 192.168.0.0. I know where that is. That's directly connected on my fast Ethernet 00 port. I will send it out that way right now for you, sir. And he sends it out. Now, the problem is, when this laptop sends it out, okay, he has his destination address, which is him, and his source address, which is the laptop himself, which would be, I think he's .3, so 20.0.3. So he gets this request, and he will send it out, because he knows where that is. And he gets it. And when Rod's router gets it, he goes, "Oh, I have mail from somebody in the 20.0.0.0 network. Oh, that's fantastic. I should send something back to him." And then when he tries to send something back to him, he goes, "Let me just check my address book." He checks his address book, and there's nothing in there. So what does he do? He files it in the shredder. Okay? So it's very important that if you can't look at these tables and figure out what port something's going to go out of, neither will it. It does exactly what you tell it to do. And so for these tables to be filled up with information of other networks, beyond what's directly connected, you need routing protocols, or you can do something called static routes. That's in the PowerPoint presentation, which we'll cover right now, and we'll also cover using OSPF. We're going to skip using RIP. It's an old routing protocol. It's not really used today. So we'll just do one static route, and then we'll do some OSPF. All right, let's do this. What are we at for time? We're at 28 minutes. Let's see how fast I can get this done. You know what? I'm just going to pause it here. Now we'll make another video using that and going through the PowerPoint presentation, just in case this shits the bed.